Welcome to the video of solving systems of equations by elimination. So in class, I went over different examples, but in this video, I'm actually going to finish the rest of the examples. So that way, if you were with me in class for the lecture, you're actually going to be viewing different examples this time. So I'm going to restate the purpose of elimination, like how the steps work and why we do it. The other method that we taught earlier was substitution. So substitution involved either both equations looked like y equals something and y equals another equation, or you had one equation for sure equal to y, and then you had x and y on the same side. You know, you had at least one letter on one side, and then that was what you knew how to solve. But this time, if you look at the examples, you don't have one equation set equal to a letter. Notice that you have x's and y's on the same side for both equations. You can't use the substitution method anymore. So this new method will show you how you can eliminate a letter so you can solve for one letter at a time. Because that's how we solve systems of equations. We can't solve for two letters at the same time. We got to isolate one of them so that way we can plug it back in. So step one is just making sure that your equations are stacked, so that way like terms are always matched up. Notice that you have x's on top of x's, y's on top of y's, and numbers on top of numbers. That way it's all nice and neat, and all your variables are in the same spot. But the whole goal of elimination is to create opposite pairs or opposite variables. What that means is, if I tell you 7, and I want you to tell me the opposite of 7, you'd say -7. Or the opposite of -5 is +5. So you're trying to cancel out the terms. Because if you have +7 taking away 7, you don't have any x's left. You're trying to get 0. So that's why we're trying to go for these opposite pairs here. What I say is the same number, both 7s, but different signs. That is the whole goal of elimination, is different signs or opposite signs, I should say. Let me just change that up. Opposite signs. So you need 1 plus, 1 minus. Opposite signs, same number. That is the goal, to create those opposite pairs. So then, once you see the opposite sign, same number, you're going to end up adding the equations together or combining the equations so you can solve for one letter at a time. Because once you actually have one of the variables, you can substitute that value back in, just like what we were practicing earlier with the substitution method. So let's take a look at least well, this one should be rewritten. So I'm going to rewrite this one as well. So I'll start off with this. This equation should be written as positive 9x plus y equals 37. And the bottom equation is written correctly. That's what your copy of the notes should read, at least. Or this example wasn't fixed, so make sure that this is the correct statement. So I'll go over the number 2 and then number 3. I did go over number 2 in class, but I wanted to give 2 examples. What you should spot immediately is the opposite number, or excuse me, the opposite sign, same number. So notice in the x's, I mean, you may not have a number here, but you should pencil in a 1, always. Always pencil in a 1 if you don't see a number. That way you don't miss it on accident, especially if it's just a negative. You want to make sure you put -1 if needed. But the problem with the x's is that they have the same sign and they're not even the same number. So this isn't a good matchup. But if you notice with the y's, you have a +4 and a -4. That's the opposite signs, same number. That means because I have that, I can combine by putting a plus sign and combining what my leftovers are. So what happens is you go top to bottom. This is a positive x, so it's 1 plus 3 more, because this is a +3. So that's 4. And since we were combining the x's, that's what gets attached to the 4. But if you type this into the calculator, the highlighted bits, 4 minus 4, you're supposed to get 0. That means you don't have a y at all. We canceled the letter. We eliminated it because it was canceled out with a 0. So I can write equals, and now I have 7, because it's a positive 7, adding 5 more, because it was a positive 5, and now I have 4x is equal to 12. There's only one step left to get x by himself. I need to divide by whatever number is attached to the x. In this case, it was 4. If there's a negative, you want to make sure you include it if it's stuck to the x, because we have to get rid of that as well. And so the question that I'm always going to ask you with solving systems is, what letter is equal to what number? Notice what letter you got by himself in the first place. You got x equals, pardon my phone, I'm so sorry. You have x equals, because you got x all by himself, and whatever 12 divided by 4, which is 3. You have a valuable piece of information right now. You now know that x is equal to 3, and so I always told you to plug it back in. The problem is that there's not an equation that automatically solves for y. But you can still plug it into whichever equation that you want. So I'm just going to be consistent, and I'm going to plug it into the top equation. What you should notice is the top equation immediately starts off with an x. Because it immediately starts off with x, and I just solved for x, I can substitute that back in. I can go ahead and open a set of parentheses and plug in the x value that I just got. And if I continue reading this top equation, this says plus 4, and then it says y. But I don't know what y is yet. I didn't get y equals a number, so if I don't know it, I gotta write the letter. And then, according to that equation, it's still equal to 7. The problem with this is you can't type this entire thing in the calculator. The reason why you can't is because notice that there's a letter involved in this equation. On the other ones that we plugged in, it wasn't like that. It had nothing but numbers, so we were able to plug it into the calculator. But this is no longer the case. So it's just a little bit of extra work. The only thing that you would be able to type is if there was a number in front of the x, like for example, there was a 1, but let's say it was 2x or 3x. You would multiply those two numbers together at least, so that way you would clean it up. Because you can type that in the calculator. For now, we have 3 plus 4y is equal to 7 still. We just have to solve for y. The problem is, I'm afraid that you're going to move this term over. Y'all are so used to moving the second term over to the other side when this isn't the term that you should move. Notice that this number is stuck to the y. It's glued together. I have to get rid of the number that's not attached to the letter. And unfortunately, that's this positive 3. This is the number I should move. So the opposite of positive 3 is negative 3. And what you do to one side, still do to the other. And so now my leftovers are positive 4y is equal to 7 minus 3, because I'm just copying the signs from top to bottom, is equal to 4. And so now I have to divide by whatever number is stuck to the letter. And so again, I'm going to make you practice what letter equals what number. This time, you solve for y, so you got y equals, and 4 divided by positive 4, oops, look at me, thinking nothing but 4s. 4 divided by 4 is 1. So now you have to create your coordinate point. Remember, it's always x, comma, y. Your x value was 3, and then you got an answer of 1 for the y. So again, even if you solve for y first, be very careful because you have to know what letter you're solving for. Because maybe, like I said before, maybe you're going to solve for y first. In fact, that's probably what's going to happen on number 3. So with number 3, I rewrote the problem, so make sure you documented that. And also notice once again, I have a y right here. I don't see a number. Go ahead and pencil in the 1. That way you just don't miss them, because there's so many little things that could go wrong with this. So again, you should be aware of opposite signs, same number. Check your x's, check your y's to see if it's already given to you. Notice which letter that you can highlight. Your x's. Because opposite signs, same number. Even though you don't see a plus sign, it's positive because it doesn't have a negative. So you got to see a positive and a negative value of the same number. And now, because you were able to highlight that, because you saw the opposite sign, same number, you draw your plus sign and a line, so that way you can go ahead and start combining. If you go top to bottom with the x's, that's 9 minus 9. It's supposed to get you 0. If it doesn't, something is wrong. You got to make sure you have that pair to make 0. So that cancels. And now we have positive 1, adding 2 more. So that means I actually have 3y, because again, I was combining the y's. So make sure the correct letter is getting stuck to that number. And then if I go top to bottom in here, I have 37, taking away 7. So that leaves me with 30. And then divide by 3. Sorry, I meant to change it with the color. There we go. Dividing by 3 to make that letter all by himself. Again, what letter equals what number? You got y all by himself, and positive 30 divided by positive 3 is a positive 10. But be careful, because for number 2, we got x equals 3. So we plugged it in for the x value. Notice what you solved for this time. You solved for y. So make sure you plug that in for y. And again, it doesn't matter which equation you plug it back into. Me, for the notes' sake, I'm just going to plug it into the top just so I can show you that I'm consistent. If I'm going to plug it into the top equation, for sure the first number that I see is a 9, but then I see x. I didn't get x equals a number. I don't know it, so I'll just put it. If you want to, you can put the plus 1. Sometimes, if you don't want to, that's totally okay, because, I mean, it's just redundant anyway. But notice that you have the y. So because you see y and you did solve for y, open up a set of parentheses. Every single time that you are going to plug something in or substitute something in, always put it in parentheses. So I got y equals 10. Now I can close them. And according to the equation, it's still equal to positive 37. Again, notice what's the only thing you can type in the calculator. Only those numbers. So only do this. Positive 1, or if it was a negative, make sure that you include that as well. Big issues. Positive 1 times positive 10. Of course, nothing really changed there, but you will have that happen in your other examples. So now you have 9x plus 10 is equal to 37. So notice how this one's just a little bit different. Last time we moved this number over to the other side. But this time this number is stuck to the x. I can't do that. I got to move this 10 over. So the opposite of positive 10 is minus 10. So my leftovers are going to be 9x is equal to whatever 37 minus 10 is, which is 27. And then the number that's stuck to the x is positive 9. Again, if there's a negative, you want to make sure you include it. And what letter equals what number? Notice again what letter you just solved for. You got x all by his lonesome self, and 27 divided by 9 is 3. So now you got to think about your coordinate point. Remember, it is x, comma, y. So please don't put the 10 first on accident just because you solved for it first. You said x equals 3. So put that number first, and then comma your y value, which is 10. As you can see in the notes, this is a level 1 question, meaning no multiplication required. You just saw immediately the opposite signs, same number. If you look at the rest of the examples in this foldable, these notes, you don't have that case anymore. I mean, on number 4, you might be able to say, well, they have the same number, but they're not opposite signs. If you don't see opposite signs, same number, you are not ready to highlight. And if you're not ready to highlight, you cannot combine those like terms. You are supposed to be able to cancel the letter with making it a 0. But if you put the plus sign, I mean, that's going to get you 5x and that's going to get you 14y. That doesn't cancel the letter. That doesn't solve your problem. I worked on this one in class, so I'm going to go ahead and actually jump down to number 5 and number 6. Because with these, again, your goal is to get opposite signs. So let's focus on that first. Notice over here again that you don't have a number. So again, pencil in the 1. Always do. Trust me, it's not going to kill you. So if you notice with the x's, we have the same sign. Ooh, I see another x too, so I better put a 1 right there as well. But notice that these are the same sign. Honestly, I don't want to deal with the x's right now because they're already the same sign. I check out the y's and notice that I have a positive 1 and a negative 4. I have my opposite signs here at least. That's a good thing. But I know that I can change this positive 1 to make it the opposite of negative 4. Because the opposite of negative 4 is positive 4. So what I'm going to do is I'm going to put this entire top equation, all of it. Notice that I'm putting the entire thing in parentheses here, not just the first part of the equation, all of it. If I multiply by a positive number, I'm not going to change any of my signs. And that's kind of what I want because I notice that I already have opposite signs. I want to keep them that way. But I can change this to a positive 4 so I can create the pair that cancels. So I need to multiply. I need to distribute this 4 to everybody, including the 12 on the other side of the equal sign. Because if I'm multiplying this side by 4, I better multiply this side by 4 as well. And that's a big mistake that I'm always going to see with y'all. So 4 times negative 4x is going to be negative 16x. Positive 4 times positive 1y is going to get us positive 4y. And 4 times 12 is going to be equal to 48. That's the top equation. I didn't do anything to the bottom equation, so I'm just going to go ahead and write it down. Negative 1x minus 4y. Well, looky there. I'm starting to already see opposite signs and same number. And then this is still equal to 3. And because you can physically highlight a positive number and it's negative of the same number, I'm ready to draw that plus sign and go. So make sure again that you go top to bottom, negative 16 minus 1. You should have negative 17x. And then you would type in 48 plus 3, and that gets you an answer of 51. And to get that letter all by himself, you're going to divide. And since there's a negative, you better make sure you include that negative as well in the calculator and in your work. Again, what letter equals what number? Notice that you got x by himself, and x will equal negative, yes, a negative 3. So notice again, you didn't have matching signs, or dang it, you didn't have matching numbers and different signs, and so you had to make some adjustments in order for that pairing to happen. That is the goal. You have to know how to get there so you can actually get this canceled out so you can solve for one letter at a time. Because now we're ready to plug in this x equals negative 3. And again, you can plug this into any equation you want. In fact, you can go back to the original question and ignore this red 4. You don't even have to worry about plugging into that equation. Just the normal negative 4x plus 1y equals 12. So because I'm plugging it into the top equation, I do have negative 4, because that's the first thing that I see. But now that I see an x, I did solve for x. So I'm going to replace it with parentheses and plug it in here. And because I don't know what y is, I'm just going to put plus y or 1y, it really doesn't matter, is still equal to 12. Be careful because once again, there's only one type of thing that you can type in the calculator. And it's this section, negative 4 times negative 3. Multiply that, and that does get you an answer of positive 12. And you still have the y on this side, and it's still equal to 12 as well. Remember to get rid of the number that's not attached to the letter. The opposite of positive 12 is negative 12, so I'm just going to put minus 12 to both sides. So again, notice what letter you just got by himself. Y is all by his lonesome self now, but this says 12 minus 12. Yes, it's okay to get an answer of 0. I will tell you right now that for my worksheets and these notes, there is no decimals, there is no fractions. So use that as your hint. If you're getting stuck with a decimal or fraction, double check your work. See if you typed something in wrong. Don't erase everything. Just go back and take it through the steps. But 0 is possible, and that's okay. The problem is you have to put it in the correct order now for your coordinate point. X always goes first, so it's -3, 0. I'm going to do one more example from this section, and then I'm going to do the hardest level, which is double multiplication. So again, I see an X. I'm going to put a little 1 because I want y'all to also notice that I want y'all to try to find the opposite signs, because honestly, that's the easiest part to manipulate. If the signs are already different, you don't need a negative to ruin everything. But notice in number 6 that I don't have opposite signs at all. I have positives and negatives, and it's just, but they're not opposite to each other in the letters. Like this is a +1 and +4. Those won't cancel out at all, and neither will these negatives. Because I have the same sign, one of my multiplication steps needs to be a negative number. I need to go in and have a negative somewhere. Otherwise, I'm not going to cancel anything. So I'm going to take a look at the X's. I see that this is a +4. So the opposite of +4 is -4. Oh, well, that means I can just multiply this entire top equation by a -4 this time. That way I can see if that creates my opposite pair. And make sure, again, that it's going to everything inside that equation, all terms. So because that's making a change, that will turn into -4x. -4 times -6 is a +24y. Be careful, make sure you include those negatives, because if you mess up there, it's game over. -4 times 1 is -4. And now I'm going to copy down the bottom equation because nothing happened to it. I didn't change it. And so I'm going to copy it down. And again, be on the lookout. Do you see opposite signs, same number? If so, you got to think about which letter that you can highlight or cancel. And boom, it's your X's. Opposite signs, same number. I'm ready to draw my plus sign and go. So again, top to bottom, +24, taking away 5. This leaves you with 19y. And then top to bottom, the first number that you should be typing in your calculator is -4 plus 23, because this is a positive. And that gets you 19. You would divide by whatever number's attached to the letter, which is a +19. Again, what letter equals what number? Y is the thing that you got all by himself, and this will be equal to 1. Let's plug in this information. Again, you can plug it into whichever equation you want. I'm just going to be consistent and plug it into the top. So, and it's also going to be the original equation. It's going to be the 1x minus 6y equals 1. So again, think about what you solved for. Did you solve for x yet? No? Well then, put x. You don't know what it is? Fine. That's okay. And then the equation says -6 for sure. But now that I see a y, I better open up parentheses and plug in the y value that I calculated. I got a value of 1. And then this was supposed to be equal to 1. And now I got to be careful on what I can type in the calculator. Notice that I need to type in that -6. I need that negative involved. So this will become x minus 6 is equal to 1. There's only one step you got to worry about, and that's moving that number to the other side. And so x is finally alone, and 1 plus 6 is 7. So your coordinate point has to start off with x, 7, 1. So again, if you have to do any multiplication at all, I need you to consider the signs. If you have a pair of signs that are already different, you don't need to change anything. Do not have any negatives on the outside of your equations. The only reason why we needed a negative outside in the first place was because we needed a sign change for something. But for this case, I didn't multiply by a negative number because my y's already had different signs. So another thing that you could have done was multiply this one by -4. That would have canceled your stuff out, but me personally, I hate multiplying by negative numbers. That's an extra step for me to worry about, and it's not worth it, to be honest. Look out for those opposite signs first, if you got them. Because let's take a look at these examples. These examples, I mean, these are level 3 because they require both lines to be multiplied. So let's take a look at number 10, because I want you to see what I see with the opposite signs. I want to try to make your job as easy as possible. So for the x's, I'm going to take a look. Notice that I have a positive 4 and a negative 9. I got opposite signs. Because I already have opposite signs, no negative numbers belong out here. None. So here's the quickest way that you need to do this. I'm going to switch these numbers. If I multiply this line by the 4 and this line by the 9, that will automatically get me that matching number. So here's what I'm going to do. We already decided that we have different signs. There better be no negatives on the outside. So just because I see a negative 9 down here, I'm not going to put a negative up here. These are already different signs. I don't need that negative out here to change anything. I just want the number. So down here, I'm going to multiply by the 4, the number that was attached to the x on the other equation. They just switched places. So let's distribute. Again, everybody has to go to all these terms. So let's edit our equations. 9 times 4 is 36x. 9 times 2 is 18y. And 9 times 0 is just 0. But now we distribute the bottom line. 4 times negative 9 is negative 36. Oh, wow, there's my opposite pair, same number. Basically, if you put a negative somewhere in there, you would not have created that opposite pair. I guarantee it. You could try it. Try putting a negative somewhere. Question me. Because if you don't see this happening, if you can't highlight this, you need to start over. That's your goal. If you don't see that opposite pair, same numbers, you probably distributed wrong, or maybe you multiplied by the wrong number. You need a negative somewhere, or you put too much. You got to start over because that's what you need. And then you have 4 times 3, which is positive 12. And then 4 times negative 15 is negative 60. Opposite pairs, same number. I'm ready to draw my plus sign and go. If I combine my y's, that's going to get me 30y. And then 0 minus 60 is just negative 60. I need to divide by the number that's stuck to the letter. So I'm going to divide by 30. And y, because I got y all by himself, will be equal to negative 2. So again, just because you multiply both equations by a number, you can still plug it into whichever one that just floats your boat. Me, I'm going to be consistent and just plug it into the top. The original 4x plus 2y equals 0. So if I plug it into the top equation, the first thing I'm still going to write is 4x plus 2. Because again, I didn't have an x and I still got to have all the rest of the equation. And it looks like we have a y. So I'm going to open up parentheses, plug in that negative 2. Please make sure you remember that negative. Look at all these steps that can go wrong just because you forget one small thing. And this is still equal to 0. Double check what you can type in the calculator. It's only that section. So that means we have 4x and positive 2 times negative 2 is minus 4, still equal to 0. I'm going to move the number that's not attached to the x, which is going to be this particular 4. And since it's minus 4, I'm going to add 4 to both sides. And we have 4x is equal to 4. Divide by 4. And x will be equal to 1. So that means your coordinate point is 1, comma, negative 2. I'm going to go ahead and do one more example. That way you can see where the negatives need to come from. Because notice again, you have different signs. No negatives belong on the outside. But if you look at number 10, if you look at number 11, the x's, they have the same sign. Let me check the y's. Oh, dang it, they still have the same signs. That means only one number needs to be negative, not both. If you change the equation, or if you change the signs for both equations, you're not going to get anywhere because you want only one of them to change. You need a positive for sure, but you also need a negative. So you need just one to do the change. And since all the signs are the same, it honestly does not matter what you multiply. You can switch the 6 and the 8 if you want to, or you can switch the 2 and the 5. You should still get the same answer. And so I'll do the y's since I canceled out the x's last time. So again, your distinction is to decide whether or not you need a negative on the outside or not. And we made that distinction. We said we needed one negative somewhere to cancel the signs. But I'm going to go ahead and flip just the numbers for now. And here's the beauty about systems of equations. Because we can mess around with the 6 and the 8, or the 2 and the 5, like I'm deciding, you can decide whether or not you have a negative attached to the 5 or the negative attached to the 2. It literally does not matter what you do. The only thing I care about is that you don't put both negatives. Because if you put both negatives, you're going to get to a dead end. You should be able to cancel something. And that's the whole purpose of elimination. I'm going to speed run through this. So we have 30x plus 10y is now equal to 10. The bottom equation changes to negative 16x minus 10y is equal to 18. This time, positive 18. Again, if you can't take your highlighter and highlight opposite signs, same number, start over, because I am ready to draw a plus sign and a line. 30 minus 16 is going to get you 14x, and then 10 plus 18 equals 28. We're going to divide by 14, and so x will be equal to 2. So now, again, I can plug it into the top equation, whatever I want. Because I know x is equal to 2, I'm going to have 6 and plug in my x. I don't know what y is, so I still have plus 2y, and it's still equal to 2. You can only type in a certain section in the calculator. That is a 12, and you still have the 2y equal to 2. You want to get rid of the number again, not attached to the letter. So you have that 2y is equal to 2 minus 12, which is negative 10. Dividing by 2, you got y equals negative 5. So that means your coordinate point is 2, negative 5. Hopefully this video helped you refresh your minds, and also if you missed the lecture on Friday. So email me if you have any questions regarding the notes.